Are you ready to create a powerful calculator? This is going to be a desktop GUI that is very useful to carry out mathematical calculations. Especially, it is useful for those who have problems following the PEMDAS rule. PEMDAS is parenthesis, exponent, multiplication, division, addition, and subtraction. Subtraction. Those are the orders of calculation. Okay, so we're going to show that in this application. For that, start with creating a project folder. My project folder here I created is calculator, and then create virtual environment. Once you have had virtual environment, in the project folder you install pip install pyqt6. That's it. Then create a main.py file, or you can call it server.py, app.py, whatever you desire, where we will write the code to create that GUI, desktop GUI. Okay, let's start coding. So import system, we need system to display, and from pyqt6 dot qt widgets, import qapplication, qapplication, qvbox layout, qwidget, qline edit, because that is for input field typing, and qpush button. We need push button. Okay, so that is input. Now one more importation. It will be from pyqt6 dot qtcore, import qtimer. We need to import qtimer so that we can clear the input field after the result calculation have been completed. So you can decide how long you want to keep that result. For next calculation, I will put here 10 seconds. After that, you will have the cleared input field where you can input. So once you have done that, let's start with creating a class calculator, which will be in the Q widget. And let's create a constructor diff init.self. Let's create a super. Okay, once we have that, let's give a window title, self.set window title. So here I am going to give a calculator. Okay, so that will be the window title. And then let's initialize a function self.init UI. This is UI where we'll write the function. Okay, def. I forgot to function call here. Okay, so def init UI. Okay, it's going to be self. Let's create the layout. Self.layout equals qvbox. always I'm going to do vertical box. You can create a grid layout as well, but here I'll just vertical box and entry self that entry q line edit is going to be self. Okay, once you have done that, self that layout that add widget self that entry. We're going to add the entry here. Self that button now equals q push button, and the button will have caption of calculate and self. Okay, after that, let's add button to the widget. Self that layout that add widget will be self button. Okay, once that, then connect that button that connect, clicked that connect self that calculate, the calculate function. We're going to write that function here. Def calculate self and try block in there. Self that entry that set text is going to be self string str eval self that entry that text. That will be called here. And then exception, except self that entry that set text. What text we're going to set? Error. Okay. Now is the time for timer. Q timer. We need the timer that single shot. How long? 10 seconds I'm going to give you, so that you have enough time to observe it and then ready for the next entry. Self that entry that clear. Okay, so that is the function. All we need it now, just run the function for that. App equals Q application. I'm going to put that into the empty list so that I can do styling. App that set style sheet, which will be Q widget, which will be in Q widget. Let's set the style. Background equals gray colon color equals white colon font size equals 20 pixel. Close the curly, and that is this. Now window equals calculator, the function call, and now window should explicitly be shown with window.show, because default is invisible. And system exit app that to exit from the loop after completing app.exec. Okay, so that is it. That is all the coding. So now let's see the result. Run this function, run main, and see if I did not make error. Something will pop up. Yeah, so now you see the GUI. Let's make it a little bigger. So I'm going to do this. All right, now let's go for test drive. 25 raised to the power 2, which is 25 square, divide by 25. The result should be 25, right? So let's see if that is the case. See, here you can see it. Okay, now let's try another one. So 10 seconds. See, so let's do 30. No, let's do 30 raised to the power 3 divided by 60. Let's see what it comes. See, 450. So now you can see this is a powerful GUI. You can carry out arithmetic operations following the PEMDAS rule. That PEMDAS rule determines the order of the operation, and with that you will always get the correct result of your calculations, of your input. If you wanted more user produced inputs, you can add inputs in the UI, and you can expand this. This is just a simple beginning to prove that PYQT6 has this capacity. PYQT6 is very, very flexible. If you compare that with tkinter, PYQT6 is much more powerful and flexible. Tkinter is rather limited. If you had to code this in tkinter, the, the lines of code would be more than this. Tkinter, you need to write more lines of code to create this level of GUI. So just wanted to show you today. I hope I have made the presentation clear. Please follow me, subscribe my channel for more Python web development as well as web API and other Python functions, GUIs, and applications that will be coming soon. So I will even show you how to embed styling like Tailwind CSS in the web applications of Python. Stay tuned for that. Thank you. Subscribe my channel. Thank you.